polynomials, there are two variables. The variables are x and y. X is independent variable, y is dependent variable. How do these variables vary relatively? A relative variation between x and y. But a relative variation can be either expressed in the form of mathematical or algebraic equation or in the form of graphical representation, graphical form. The relative variation between x and y can be either represented in the form of algebraic equation. These are algebraic equations, polynomials. Polynomials of different degree, first degree, second degree, third degree, fourth degree, in the form of equation or in the form of graphical representation. Either way, how do you draw the graph for different polynomials? Here, for different set of values, you can choose any set of values of x. Correspondingly, calculate what are the possible values of y in accordance with this equation. You choose a set of values of x, numerical values. Let us say x1, x2, x3, x4, set of values, either 5 values or 10 values of x. Put the value of x, calculate the value of y. These are the constants. Put this value of x, calculate the value of y. You get a value of y. Value of this, get a value of this. For a given set of values of x, we get the set of values of y. Two columns. Says that this set of values says that how does y varies with x? We see in graphical form. What is a graph? There are two variables. For two variables, we request two dimensions. Graph of two dimensions on a plane. Here, one dimension is x-axis, one line. A line represents all the values of x. Other dimension, here line, y, axis of y. This straight line represents all the values of y. This two-dimensional graph here contains all the values of x, including what is 0, minus values, plus values. This side we have minus values of x, plus values of x. Here 0. This is the origin. Value of x and y are 0. This side value of x positive, values of x negative. And this side up, the values of f, the values of y are positive, the values of y are negative. But all along the line, the value of 0, the value of y is 0 all along the x, only values of x. Similarly, all along the line, we have different values of y, but value of x remains 0 here. In between these axes, we have different points. We have different values of x and y, excluding 0. Graphical representation is very easy. Once if you calculate the values of y in accordance with the values of x what you have selected, take the graph sheet and find the points on the graph. Write all the values of x here, possible values of x on the x-axis, values of y. For every point, what is that? For every set of these values x and y, x has one value corresponding y value, find a point on the graph. We need the point. So this represents a point on the graph, x and y, one point, x2 and y2, one more point, different area, x3, y3, one more point. Find like that different points on the graph. Find out the points after these values. We need different points on the graph. Join all the points for this equation. We always get a straight line like this. Like this. This is a graphical form or graphical representation of variation of x with y, variation of y with x. It says, how does y varies with x? Say that your line says that your direction of the value of x is varying, what is that? Increasing from this point to this point. As the value of x increases, value of y increases like this, linearly, in straight line. It is called linear relationship. The relationship between x and y is linear or straight line. It is called linear equation. Equation is called as linear equation. That is the reason our name is assigned for these equations called as linear equation for first degree equation. So you always get a first order straight line for this kind of equations. Polymer equation of first degree equation. Here says that function y, value of y increases. Here value, how does y varies with x? Value of y increases as x increases. Like this. Sometimes we get what is that? A straight line like this also. There will not be like this. A straight line is what is that? As the value of x increases, value of y decreases. That is also possible. That variation or increase of y with x or decrease of y with x, it all depends on the real value. What is that? These real values carrying positive or negative, increase or decrease. A straight line like this or a straight line like this. This line represents y decreases as x increases. This straight line says that y increases as x increases. That is a graphical representation of first degree equation. What is the graphical representation of second degree equation? Like this only, you can write. You can calculate like this. This is an equation form, mathematical equation form of relative variation between x and y. Quadratic equation, of course. These are the functions of x. So likewise, choose a set of values for x. Some set of values of x. Calculate the values of y. Corresponding values of y. Using this equation. What equation you have like this? Here equation containing definite numerical values. We get these values of this. Take the same graph sheet like this. Put the dots like this. Join the dots. We get a what is that? Not a straight line. A line gives a curve like this. Join them all the lines, points. We get a curve like this. The curve is parabola, shape of parabola, cup shape. They are concave shape. It may be what is that? Concave up, concave down. Your cup up, cup down. Maybe. It all depends on cup up or cup down. It all depends on the nature of real values. These are real values, maybe positive or negative, positive or negative. Here maybe like this or like this. It shows that how does y vary with x. Y vary, no, variation of y with x. Here value of y varies like this with the variation of x. Value of y decreases as the value of x increases like this till the point, and then value of y increases for further increase in x like this variation. Once decrease, other time increase with the increase of x. Here value of y increases, then value of y decreases with the increase of value of x. One time increase, other time decrease. This is the nature of, this is called quadratic equation. It's a parabolic shape. It's always a curve for a quadratic equation, second degree equation. This is a kind of graphical representation. It's a graphical representation of quadratic equation, polynomial of degree 2. What is the graphical representation for the polynomial of degree 3? This is polynomial of degree 3. Similarly, we can calculate what is that? Set of values of I for a given set of values of x. Like this. Using this equation. Take a graph sheet, put the graph, find the points on the graph, put the point, join the graph, join the points, we get a curve like this. A wave like this, similar to this curve. Need not be exactly same, similar to this curve like this. This is a kind of graphical representation, variation of y with x. What does it say? Here y increases, then y decreases, then y increases, while x is keep increasing all the time. This is a fluctuation. Fluctuation of y. How does function y varies? Here fluctuation, one time increase, other time decrease, other time increase. This is how function y varies with the variation of x. This is a kind of graph. May not be same, but it will look different, but same kind, almost same shape like this. This is for what is that? Polynomial of degree 3. Equation 3. Similarly, when you draw a graph for the fourth degree equation, graphical representation for the polynomial of fourth degree is the equation form. The same similar procedure we follow for a given set of values of x. Assign any set of values of x. Take this. Calculate the values of y, corresponding values of y using this equation like this. Any equation like this. Take a graph sheet and find the points on all the graph sheet. Put the points for the set of values x and y. Join the graph. We get a graph like this. Again, like something wave like, not symmetric, unsymmetrical wave like this. So here says how does y varies with x. Along there, what is that? Variation increase. As the value of x increases, value of y decreases, then increases, then decreases, then increases like this. It may be like this, up or down. The shape here like this, W like this, or W. Not symmetric as that, similar like this, shape like this. Here sometimes it depends on what is that. Here increase, decrease, increase, decrease. Y increase, decreases, increases, decreases with the increase of x. Continuous increase of x. Either this or this. Shows that variation of y with variation of x. Graphical representation in 2 dimensions. How does value of y varies with x? This is a graph we get. This is what is that? Graphical representation of polynomial equation of 4th degree. You see that we have both mathematical form and graphical form. Mathematical form is algebraic form algebraic form of different degrees, graphical form of different degrees. Here for first order degree, graphical form, second order degree, shape like this, maybe like this something. Yeah. Third degree, we have a shape like this. Fourth degree, we have a shape like this, either this or this, depending on what is that. This either up or down, it depends on what is that. The real number. The real number either carry positive or negative. Depends on the real numbers. You get like this or this. This is how we understand what is that polynomial equations in both what is that algebraic form and geometrical form. And one more important what is that in syllabus, you not yet started syllabus, I want to stress upon what is that zeros of polynomial. What is meant by zero of polynomial or root of polynomial? You come across in the 10th standard meaning of zeros of polynomial. Determine the zero of polynomial or root of polynomial. What is zero of polynomial or what is root of polynomial? Here, in this first degree, polynomial of first degree, look at this graphical representation. This line what you get, graphical representation of a variation of x and y. This line intersects at the x-axis at only one point. Any point on the x, value of y is always 0. Here, at this point, value of y is 0, but value of x is not 0. Value of x has some finite value. This value of x. This value of x of this equation, when y equals 0, it is called zero polynomial. It is called zero polynomial or root of this polynomial. What is the root polynomial? First degree equation or what is that? First degree equation, root is only one root. Zero of this first degree polynomial is only 1 0. That is 0 means it is not 0. Then y equals 0. What is the possible value of x? This is a possible value of x. Yeah, you can find out from the graph directly. What is its value? You can also evaluate using the equation. There is a mathematical problems you come across later. But understand what is the meaning of zero polynomial or root of polynomial. Here only one root. First degree equation has only one because graph says intercept only at one point on the x-axis. Only intercept on the x-axis, not y-axis. Intercepting at only one point, it has only one root. It has only one zero polynomial. That is when y equals 0, what is the possible value of x? The possible value of x is called as zero polynomial. A definite value for x is called the root of the polynomial, first degree equation. Similarly, what is the zero of this polynomial quadratic equation? Here look at this curve, understood that this line, the curve touches the x-axis, intersect the x-axis at 2 points, this point and this point. Here also this point and this point. Here some value of x, some other value of x. But y equals 0, y equals 0. When y equals 0, there are two possible values of x. This is one value, other value. These values of x are called as zeros of this polynomial or roots of this polynomial. How many roots we expect from the quadratic equation? 2 roots. That is possible values of x when y equals 0. Directly understand how many roots we have in the graph. Intercept either this graph or this graph. It is the meaning of zero of the polynomial, root of polynomial. Every quadratic equation has 2 roots. Every first degree equation has linear equation has 1 root. Linear equation has 1 root. Quadratic equation has 2 roots. Similarly, we have third degree equation. Look at that. From the graphical, what is that we understand? From the graph, understand. Look at the graph is why that intersecting the line x-axis at this point, and this point. So at this point y is 0, all along no, y is 0. This point y is 0, y is 0, y is 0. When y equals 0, there are three possible values of x. This is one value, this is another value, this is another value. But this value is not 0. X is 0 is here. This value is not 0. These are the possible values of x. These values of x, when y equals 0, it is called as 0 of this polynomial. Also called as a root of this polynomial, a root of cubic equation. How many roots are possible? 3 roots. So 3 values of x are possible when y equals 0. Similarly, when you look at this 4th degree equation, look at this graphical representation. In this graphical representation, the curve, what is that, intersects the x-axis at this point, this point, this point, and this point. 4 points. Either this or this. Intersect at this point, this point, this point, this point. So 4 different values of x when y equals 0. So here, when y equals 0, the possible values of x are 4 different possible values. From the graph directly you can read, or you can evaluate using this algebraic equation. The evaluation is there, problems. They are called as roots of this equation. This equation is 4th degree equation or quadratic equation. How many roots are possible? 4 roots are possible. Here, zeros of this 4th degree equation, 4 zeros. That is zeros of polynomial or roots of polynomial. Is understood? Here, roots of polynomial or zeros of polynomial. What is polynomial? Polynomial equations. What are different types of polynomial equations? We have types are classifying on the basis of degree. What is that? First degree, second degree, third degree, fourth degree, fifth degree, sixth degree. Like that we have degrees. And each degree of polynomial has its own roots. First degree has only one root, second degree 2 roots, third degree 3 roots, fourth degree 4 roots, fifth degree 5 roots. Different roots. Root means when y equals 0, what are the possible values of x? Either graphical representation from the graph, after drawing graph only we can understand what are the possible values of roots. Directly you can evaluate using the equation. What is that? Algebraic equation, polynomial. There is a procedure is there. This is a syllabus. So now it is important to understand what are polynomials. Polynomials general equation is this. From this equation we can generate different types of polynomials. Here, first degree polynomial of first degree, polynomial of second degree, polynomial of third degree, polynomial of fourth degree, and so on, polynomial of fifth degree, and so on. Like that, we have different polynomials and meaning of roots of polynomial. With this, let us wind up this class. Next class, we can able to find out how we can able to evaluate roots of the polynomials, different polynomials. Here quadratic equation, we don't have this equation for this. Yeah, we have roots of this quadratic equation, roots of cubic equation. How we can find out using algebraic polynomial, algebraic equations. Next class.